Hello, and welcome to Lab 2, Part B, Investigating Plate Tectonics Using Google Earth. In Part B of your lab, we will take a look at seafloor spreading based on the ages of the oceanic crust. We will calculate the average production of oceanic crust given the radiometric age and the distance from the divergent plate boundary. To begin, turn on layer Part B and turn off layer Part A. Next, expand layer Part B. Under Part B, you should see the seafloor age layer and layers A through F. Then navigate to the mid-Atlantic ridge by double-clicking layer B. You will need to zoom in and readjust your view to match what you see here in this video. In your screen view, make sure that you can see both points A and B. Remember, when you readjust your view, you may need to reorient to the north by either typing R or by clicking the little circled N near the top right corner. Point A is positioned along the mid-Atlantic ridge where we see the youngest oceanic crust marked in red. Point B is located off the east coast of the United States, where we see the oldest crust marked in purple. You can determine the age of crust at various locations by using the map legend. For example, the oldest crust is approximately 180 million years old. Let's examine the ages of the seafloor across the ocean basin. Using the ruler tool, let's measure the distance in kilometers from the mid-Atlantic ridge at point A to the oldest crust at point B. Simply select the ruler tool, click near point A, then click near point B to measure the distance. You can move the ruler dialog box anytime if it's in the way. Within the ruler dialog box, Google Earth automatically provides the distance. Make sure that you set your ruler measure to kilometers. Also, round your answers to the nearest whole number. Record your distance measured from point A to point B now. Now that you have the distance to work with, let's calculate the seafloor spreading rate. To do this, we will use the measured distance in centimeters and the age of the oldest crust in years. You may recognize this formula by its general format of rate equals distance divided by time. However, we need to make some adjustments. Your lab assignment asks that your final answer be in the units centimeters per year. So we first need to convert kilometers to centimeters. For example, let's say our measured distance is 1,800 kilometers. To convert 1,800 kilometers to centimeters, we use the conversion ratio of 1 kilometer per 100,000 centimeters, which is 180 million centimeters. Next, according to our map, the oldest crust was about 180 million years old. To convert 180 million years into years, we use the conversion ratio of 1 million years equals 1 million years equals 180 million years. Now that all of our units are in the proper format, we can calculate the spreading rate by dividing the distance in centimeters by the age of the oldest crust in years, which in this example equals 1 centimeter per year. Using these processes and examples, you will now complete the table in your lab. Complete your measurements and calculations for the mid-Atlantic ridge from point A to point B and the East Pacific rise from point C to point D. Make sure to show all of your work in the table and round to the nearest whole number. Pause the video and complete the table now. Hello and welcome back. Next, we will navigate to to the South Atlantic Ocean by double-clicking on layer E, and by using the ruler tool, we will measure the regional east-west distance, or the width, of the South Atlantic Ocean. Again, you may need to zoom or move the global view so that you can see both points E and F. The South Atlantic Ocean width. To calculate the width of the South Atlantic Ocean, you will use the spreading rate that you calculated in the previous table for the Mid-Atlantic Ridge that was in centimeters per year. To set up your calculations, we will need to algebraically adjust your equation. Remember, we use rate equals distance divided by time to calculate rate, or the spreading rate. Now the equation is asking for time, or the number of years. The number of years to reach the current width of the South Atlantic Ocean. So we use the equation time equals distance divided by rate, or more specifically, the age of the oldest crust equals the distance in centimeters divided by the spreading rate in centimeters per year. However, before we calculate how long it took to create the width of the South Atlantic Ocean, we must first realize that the spreading rate, calculated from the previous example, was for only one side of the total east-west width of the ocean. Thus, we need to half the total east-west distance that you measured. So your final formula will include half the distance. Now, pause the video and calculate how many millions of years ago the continents of Africa and South America drifted apart to create the South Atlantic Ocean. Make sure to show all of your work and round to the nearest whole number. Pause the video now. Hello and welcome back. For the final question in Part B, you will navigate to the Pacific Ocean. Notice that the same seafloor ages are present, yet the size of the Pacific Ocean is considerably larger than the Atlantic. Both are measured by the same ages from red to purple. Based on this visual observation, what can you say about the spreading rate of the Atlantic versus the Pacific Ocean? Is one spreading faster than the other? And with the seafloor ages present, do you really need to calculate the spreading rate to come to this conclusion? In your lab assignment, hypothesize whether you need to make these calculations or not, or can simply state a hypothesis based on your visual observations. This concludes Lab 2, Part B. After completing Part B in your lab assignment, watch Video 4, Part C, Oceanic Hotspots. Please address your questions to your lab TA.